doing with linear interpolation this topic. So remember that curve fitting is used to make predictions from data based off of overall trends of the data, which is much different from interpolation because, and what's confusing is interpolation is also used, is also used to make predictions. But the difference is that it assumes that the data points are exact values. So instead of looking at a whole set of data and fitting a relationship to the entire set of data, you're looking at single points that bracket a point of data that you're interested in, and you're looking to obtain an analytic relationship between specific points or in a subset of that whole data. So again, curve fitting looks like this. You have a bunch of data. And you fit a curve to the overall trend, where interpolation means that you have a certain point that you want within your data, and you're using just the points around it to find information about that point. And you can interpolate with 2 points, and that's linear interpolation. That's what we're doing. But you can also do higher order interpolation. So if I wanted to know what this point is, or let's look at a point between these two. Let's say I wanted to know something about this point here. If I used 3 points instead of 2 points, I would get some information about the curvature of this relationship. And so it would be a little bit more accurate if your data, really that was the relationship of the data. But actually, typically, linear interpolation is fine for what you're going to do in most engineering classes because you're usually going to be using it for interpolating data from tables. So again, here you're assuming that there's random fluctuations, so you're just looking at an overall trend. Here, you're assuming exact values, and you're trying to approximate a value between data points. So it's a different thing. So I think a lot of you have seen linear interpolation before. So I guarantee, I used to say the stupidest things. So you're not just programming the linear interpolation formula. That would take like 1 minute. You're programming an algorithm that can automatically determine interpolated values. So it is actually quite a more sophisticated algorithm than the previous 2 that we've done, which is why I'm setting it up a little bit for you. So we're going to start by just making sure that everyone's on board with the interpolation formula. So if you've had it before, this should be review, and if you haven't, then you'll see where it comes from. So what we're saying is that we have two data points. We're going to call them x1, y1, x2, y2. So imagine it's like these 2 points right here on either side of the red point. And we're trying to approximate the y value for any x that is between the 2 points that you're interpolating from. So the only requirement is that the 2 points bracket the x point. So we'll draw out the 2 points and we'll label them. And then we'll draw out an example x point. And the standard notation with interpolation is that the interpolated value uses a star. So I'm going to call it x star. So along with their x values, each one has a y location as well. And you know x, x1, y1, x2, y2, but you also know x star, and you're trying to find y star. I'm just rewriting it because I'm using the star notation, so you can really be clear with what you know. So, for example, when you write your interpolation function, these 3 things are going to be your inputs, and this is going to be your output, the y star. So we just need to find this y location, which I've already visually located because I know I'm using linear interpolation. And we're just going to find the y location of this x star by creating a linear relationship between the 2 points and then locating where that point falls on that linear line. And so you just need to write an equation for that line and plug in x star. Or you can use similar triangles, which is more fun, so that's what we're going to do. And then we're just going to write out all of our heights. So this height of this triangle is y2 minus y1. The height of the littler triangle is going to be what? Y star minus y1. And then we'll also need the widths of the triangle. So the overall width is going to be x2 minus x1. And then the smaller width is going to be x star minus x1. So similar triangles means that they both have the same angle at this side. So we can use SOHCAHTOA to say that the TOA, the tangent of this angle, should be equal to the opposite of or adjacent of both triangles. I don't know why Joel's laughing at me, but this is great. So we can just do the opposite over adjacent of each triangle is going to be equal. So I'll do that. So we'll do opposite over adjacent of the little triangle is y star minus y1 over x star minus x1. And then the bigger triangle is going to be y2 minus y1 over x2 minus x1. So that's how we can relate our 5 unknowns to our known, right? So that's a relationship between all 3 of those. So since our unknown is the y star, we're going to solve for it. And this is the linear interpolation formula that you'll see if you ever look it up or if you ever use it. So we have y star, just doing some algebra and rearranging, equals this. Okay, so this is your linear interpolation formula. So what I'm going to do, because of this thing we're going to do up here, instead of having to like plug this into our calculator each time, I'm going to program this up in a function so that we can use it anytime we need to know if we have 2 points, what any point in between is, okay? All right, so I'm going to switch over. I will go back to the notes. So what I'm going to do is I'm going to have this read in all of our knowns. So x1, x2, y1, y2, and x star. And then what's my output? Y star. So then I'm just going to write out this equation here. So just plugging in the arithmetic. So you will need to do this. You don't have to put it in a separate function like this, but you can, because your algorithm is going to be have a lot more going on. But this is just to get that value. So if I want to find, if I know an x and a y combination point, and I have a point between, then I can find the y star from running this function here. There's an intrinsic function that does this too. Okay, so what we're going to do then, I'm going to use that function, is we're going to talk about what you're going to do in the lab. So in the lab, what you're going to do, just think about this as an example. There's going to be a couple different examples. So imagine that you collected data every 2 seconds. So you were doing some experiment where you're collecting data, and when you ran the experiment, you collected it every 2 seconds. But after you were done, when you were doing your analysis, you realized that you needed it every 1 second. Okay? So that's what the lab is having you do. It's assuming that you have some set of data on some domain, reinterpolate it onto a different domain, basically. So it's like this, if you want to see it visually. And I'm going to use the same notation. So you collected data every 2 seconds. So you have some data. But you needed it every 1 second. So you needed to add 3, 5, 7, probably had a lot more data. So you had to do it a lot more than this. So what you have to do is find that interpolation many times, right? You have to find an interpolated point many times, and an unknown amount of times. It depends on what was inputted in. So you need to find these locations between all of those 2 second collected data. So this is lab 10. That's the algorithm that you're going to be writing. You're not going to be writing the function that I just wrote on MATLAB just now. That's just a small piece of it. So I have an example to show you how to do the algorithm. So I don't know what it's called. I probably should, but I just call it the window interpolating algorithm. I think that I made that up, but you can try to Google it. Probably will anyway. Okay, so I had a choice to do an example that was really practical and useful, or an example that was fun and actually not really a thing that you would ever do. And I chose the second one. So I don't want to hear about it. I made the choice that it doesn't make any sense that you would interpolate this data, but it's way more fun, so just come with me on this journey, okay? So this is the data that I chose. Also, I made it up. I made up the data. It's not real data. So the X data that we're going to look at is number of texts sent or received per month for an individual. And the Y is the age in years of the individual. So I'm just saying, if you had some information about someone's age and how many texts they send per month, then perhaps if you knew how many texts someone sent per month, you could predict their age. Right? That's what I'm doing. So here's the data that we're going to be using, and I'm actually going to need 12 volunteers. So as we write out this data, think about if you are going to be one of those people, because that's like 10% of the class. Here's the data, and do write it down. It will help you when everyone's up here if you have this written down. So let's say that I collected data from 7 individuals. I found out how many texts they sent per month for a given month. Actually, this isn't real data, but it's based off of real statistics. I didn't make this up. And then you collected information about these individuals' ages in years. As you can probably tell, there is an obvious relationship between this data, which is basically fairly linear or just increasing with age. And the other thing we need is our X star. So remember, it's not just one value, but it's actually a bunch of values. So let's say that I knew five other people, and I happen to know how many texts they sent and received that month, and I want to use this relationship to predict how old they are. Okay? So I'm going to linear interpolate properly between the right points to find how old each of these 5 people are. So let's start with just plugging it into the function that we wrote, and then we'll do the exercise up here to write out the algorithm. So if you have it written down, I'm going to call this function, and I'm going to start by using myself as the first data point. So the first X star is me. I sent 151 texts and received 100, that was my total last month. So I want to see what this would say how old I was. So I'm going to go and plug in my linear interpolation function, the proper points. So I need to find the texting points that bracket my number of texts. So that would be an x1, I'll just type it out first. My x1 would be 100. My y1, 100 text is equivalent to a 75-year-old. And then my x2 is 421, right? Is that right? And how old is for that one? 66. So I'm going to call my function, and I'm going to look back at how I set up the function. I did x1, x2, y1, y2, x star. So I'm going to put it in that order. So I'm going to do x1, x2, y1, and I didn't have to put these in as variables, I just did. So I would be 73.6 years old. So it's really a good way to do this kind of thing. Now we're going to do that with the rest of the points, but we're going to create the whole algorithm. So, and then I'll write down the steps for you. So I need 12 people to come up on the stage, and I did not pre-select you. So just going to wait until 12 people come up. You don't have to if you don't want to, but I need 12 people to come up here. Once you come up, just come to a board and just pick up the board. Just stand wherever there's a board. So I need 4 more. One more. Not forcing you. Would have hated doing this myself, personally. Appreciate your confidence.
Just help. I think.
There is one more, Phelan. We need you. So, unfortunately, what you didn't know is what you guys were putting yourself into. So you are the 5 x star points, and then this is the array of x and y's that are coming into the function. So this is the same, it's sort of the same as what you wrote down on your sheet. So now that you guys are sitting here, the first thing that I want you to think about is we need to find where those 5 people, what the values of their y stars are for each of them, right? So we need to think about what we need to do in order to get to that goal. So the first thing is these are out of order, right? So what do we need to do before we do anything? We need to get them to sort. So you 7 need to sort yourselves.
From what?
Years? 19.
By x. By x, because x is what we know, right? We know the x values.
You're in that one. You stay right there.
All right. Let's go that way. I'm okay with that. Do you want stars to mix in too?
Not yet.
Oh.
What's yours? Oh, you're starting. Can you guys, the stars just go over a little bit?
No, you're good.
Okay, so they just sorted. Do you remember in week like 4 or 5 when we wrote the sorting algorithm in class? Is that what it was? How those humans just sorted? Not at all, right? Humans do not think like computers. So they just did their own sort. But you guys don't need to write the algorithm that they just did. You can just use the intrinsic sort function. So the first thing we did is that we got them sorted. Now, we need to start somewhere, right? So what was the first x star value that I gave you? The 151. So what does 151 need to do?
Find a way in between.
He needs to find his window. So he found his window, and once he found his window, what does he need to do? He needs to find his y star value. And he's going to do that by using the function that I just wrote, and we already did it. So what is his y star value? 73.5. So you can write that in. Upside down. That's
Impressive.
old 5 stars.
I almost messed it up.
Okay.
All right.
What was the next x star value? 121. So x star 121, you need to find your window.
Wait, 1, 2, 2, 1.
Oh, 1, 2, 2, 1.
12, 21.
Okay. So you found your window. Now you need to find your y star value. So to do that, I would just take the 2 bracketed points and plug it into my function. So what is the x1?
1, 2, oh.
What's the one on your right?
961.
961. And what's the one on your left?
1475.
And what's the y one on your on your right?
49. Y2 is 35.
And then what's your x value?
1221.
So he is at 41. And you can check to make sure that it makes sense. So, 13, I see. Yeah, so it's in between, so it makes sense. And so we're going to repeat that with the other 3 y star values. We're going to put them in a window and find their y star. And so what we're going to do now, you guys can all put your boards down and go sit down. Thank you so much for coming up here. Is sorry y stars that didn't get your window. Your standing there was enough. We're going to write down what we just did in steps, okay? So the thing that you'll notice is that the one thing that we did is we had to repeat something many times with the x star values. So that's one loop. And then we also had to repeat finding windows, and that's another loop. So it's going to end up being a double nested loop. And there's a lot of different ways you can do it. I'm just going to write down on the steps, and we're just going to talk through some of the options. So let's do that. So what was the very first thing that we did with that exercise? What was the very first thing that happened? that took a while because no one wanted to come up here. Even before sorting.
Fine.
Get volunteers, right? So we had to get the data. We had to receive the data somehow. So we had to get people to come up here. Yeah. So we need to get an array of x's, an array of y's, and an array of x stars. So we need that information first. So just imagine you had a line of xy data, and then you had a group of x stars that needed to be placed. Then, as you guys said, the first thing that you need to do is you need to sort x and y. They need to be in ascending or descending order, and they need to be sorted in order of x. Okay, the first thing that we did after that is I like to write out the steps in this way because I think it makes it easier to connect it with the computer equivalents. But we started by looking at one x star value, right? And what was the first thing that that x star person had to do? He had to find a window. And what was the condition for the window? Yeah, it had to be bracketing the x. Once you found your x1 and your y and your x2, when you found that window, the next thing that they did was they used the linear interpolation formula to predict the y star. So again, I wrote it in a function that I just called on, which you're welcome to do the same thing, or you can plug this directly into your interpolation function that you're writing. You don't have to have a separate one. After we did it for one x star value, what did we do after that? We did it for the next x star value. And we only did it for 2 because I felt like everyone wouldn't be able to handle doing it for all 5, but you need to do it for all of your x star values. So you need to repeat number 3 for all x star values. And then the last step is important, which is after you do all of that, you have to then report back what you found. So there's a lot of steps that aren't included here, but you somehow have to keep track or keep an array holding all those y star values. So now that we've written out the general steps, we're going to write out what this would mean when you start programming. So getting these, they're going to come in as input. So I already told you that. Doing step 2, you're going to just be able to use the sort function, or call the one that we already wrote, because we already wrote a sort function. Or secretly, you don't have to do it because the data is already sorted before it comes in for this lab. But to be general, you should make sure it's sorted. Okay, so then finding the window is where the majority of the algorithm will be, and you've actually already done an algorithm very similar to this in previous assignments. So there are a few different ways you could do this, but you basically need some sort of repeated condition checker. So you've done this when you've done like finding values. Do you remember when we did that? It's the same thing. You basically need to find when x star becomes bigger than an x. Once it becomes bigger than an x, then you know you're going to be bracketing. You're going to have two things that bracket. So you can either do a while loop or a for loop with an if statement, but you just need some sort of repeated loop checker. So either one of those will work. This is just going to be a definition inside that condition, and it will need to be some sort of definition that's accessing proper indexes of an array as well. And then what about number 4? What do you need for number 4 to repeat for all x star values? A for loop, right. And you can use a for loop by itself because you will know exactly how many x star values you have by just checking the length of x star. So you'll know exactly how many times you need to do this. And then lastly, this will be an output. So that's the algorithm. So I hope that helps you at least get started thinking about this lab that you're going to be working on. There is not one way to write this. There's a million ways. So I encourage you to really think about your window interpolation. Like, this part is the trickiest, part A here, and there's a lot of different ways you can do it. So I encourage you to really think about what makes sense for you to do this. I 100% know that you can find an M file that does this very easily on the internet. And I see people do it all the time, but that's not going to help you. So just write it yourself. There's so many different ways you can do this algorithm that I really want you to come in with whichever way you want to give a shot, and the TAs will help you sort through and get it working. Okay, there's a couple little subtopics that I want to just emphasize as you get started with this. The first thing is the idea of extrapolation. So please note that extrapolation and interpolation are two totally different algorithms. So you don't need to allow for extrapolation in your algorithm. So you need to assume that all of the values that you're interpolating to fall between the greater bounds of your data. So let's say you have some data, which I'm going to put as black dots. Interpolation will allow you to find data that falls. I did it again. I'm really failing at the video. Interpolated data means that the interpolated points won't be outside of your lower and upper bounds. And an extrapolated point would be a point that falls on either side of the bounds. You can do that, it's fine. Usually you do some sort of fit to several points, and then you can find what point would be right outside of it. But that's not what we're doing. So for example, a really good check to your algorithm before you even make sure that that condition is true. So make sure that none of your x star values are outside of those bounds. That would be a condition that would be in most interpolation algorithms. The last thing that I wanted to talk about is higher order, which you might have noticed was a topic of this past quiz. So we did linear. So linear interpolation is equivalent to a first order polynomial, right? This will also help you a little bit with using the intrinsic interpolation functions. That means that you have an equation that has two unknowns that you're trying to get enough information for to fully define. So that means you have two unknowns. So how many points are required to solve that? If you have two unknowns, you need 2 points. So you'll notice that this is always going to be 1 plus the order of the polynomial you're trying to fit. And so this just looks like 2 points, and you can find any point between them with a straight line between them. So if we go up to quadratic, what that looks like is now you have order 2. So you're trying to fit to a quadratic equation. So you have 3 unknowns, so now you need 3 points. So let's say you have 3 points like this. A quadratic interpolation function would first create a fit between the 3 points, and then you could predict any point along those lines. So it's a little bit different in that it takes 3 points, you make the fit, and then you could find an x star anywhere along that line. So that would be a higher order interpolation function, which is something you would do in a class like 303, is be able to write the algorithm general so that it could do it for any order. And then obviously as you keep going up, it's just going to continue to add points, and then you can continue to fit. And this notation too is very consistent, where you use the A0, A1, A2, A3. The only thing is that in MATLAB, since there's no 0 index, they always start everything at 1. So if you ever see something written for MATLAB specifically, it'll always start with 1, but most math equations and stuff always start with 0. Okay, I think that's it. Does anyone have any questions? Okay, thanks.